What's going on, everybody? Today, here to talk about Nostr. I think it's Nostr, but I've been seeing this pop up a lot today. Elon, Twitter, proposed that a couple other social networks can't be promoted openly on the site on Twitter. And one of the things they mentioned was this thing called Noster. Now, there's very little details about it. Seems to be of relevance as Jack donated about $250,000 to the developer behind Noster. And I think as an application, a protocol, whatever you would like to consider it, Noster has been in development for a little while. But, for something to be only brought into, if you can consider Jack mainstream relevance to end up in a Twitter policy there might be something there. And, I've been in the software industry for a while now. I've been into crypto, decentralization, cryptography, all these various protocols that, stem from these blockchain projects. And I feel like the biggest thing that they miss, there's very smart people behind these protocols, these applications, but they explain it. They explain their software. They explain their solution to other very techie people. You see a tweet like this, you think that Jack, the CEO, the former CEO of Twitter, was just hacked or something like that, or a cat walked across his screen. I think everybody in software knows what a public key is, but how many people who use Twitter would actually know what that is? And I think there's something here, and I think Elon has seen it. I think the high-ranking people at Twitter, Jack, has seen it. There's something here in this protocol, and I want the education around it to be a little more friendly for the average person. And that's what this first video is meant to be. Some preface. I'm new to what Noster is. I'm learning along with you. I'm just bringing my various knowledge to help explain what the heck is going on. Because from what I've seen so far, I think people are going to miss out on something that could be big and something that might only be available to the tech extremists. Let's go to this app called GitHub. This is where a lot of the world's code is stored on. And this is the Noster GitHub repo where you can see the code behind it and other resources on how to get involved in it, other projects that are building on top of Noster, and so on. The opening copy. Noster. Notes and other stuff transmitted by relays. The simplest open protocol that is able to create a censorship-resistant global social network once and for all. It doesn't rely on any trusted central server, hence it's resilient. It is based on cryptographic keys and signatures, so it is tamper-proof. It does not rely on P2P techniques, therefore it works. Now, I've been in software for a while. I don't really hear relay thrown out loud. It may be due to my field of work, but the only context I've ever really seen that be used in a more mainstream use is in internet relay chats. And from what I've gathered in this context, relay is just another term for a server. And very short summary of how it works if you don't plan to read anything else. Everybody runs a client. It can be a native client, a web client, etc. To publish something, you write a post, sign it with your key, and send it to multiple relays, servers hosted by someone else or yourself. To get updates from other people, you ask multiple relays if they know anything about these other people. Anyone can run a relay. Relay is very simple and dumb. It does nothing besides accepting posts from some people and forwarding to others. Relays don't have to be trusted, and signatures are verified on the client side. So let me quickly run through what the signature process is. So this is Jack's public key. This is, a collection of numbers, letters, etc. that are unique and they can identify Jack. The odds of someone else having this randomly generated combination of numbers, letters, etc. Statistical probability of a person having this same public key is almost never going to happen. So say I'm Jack and I'm writing this tweet that will be part of the Noster protocol. So this is my tweet verifying my account on Noster. This is my public key. I'm going to use this key to associate a digital signature, like a handwritten signature. And there's going to be some computer algorithm that encrypts this tweet, or whatever the equivalent of a tweet is on Nostr. What gets sent to Nostr is my public key, an encrypted version of this tweet, and my signature. And then what hashing algorithm, what computer algorithm I used to create a signature. And then it's going to get sent to a Nostr relay. It's going to store that there's a tweet or a Nostr equivalent of a tweet coming from this public key. This is the data. This is how it's signed. It's going to pass that tweet along to anyone who makes a request. It's up to the person's computer to decrypt that tweet and get the contents of it. Now that sounds extremely complicated. It is, but from a user standpoint, the computer is going to do all of that work for you. So I'm going to explain more about this through a series of videos. I'm going to wrap this one up with how does Nostr work. There are two components, clients and relays. Each user runs a client. Anyone can run a relay. Every user is identified by a public key. Every post is signed. Every client validates these signatures. Clients fetch data from relays of their choice and publish data to other relays of their choice. A relay doesn't talk to another relay, only directly to users. For example, to follow someone, a user just instructs their client to query the relay it knows for posts from that public key. On startup, a client queries data from all relays it knows for all users it follows. A post can contain any kind of structured data, but the most used ones are going to find their way into the standard, so all clients and relays can handle them seamlessly. So that's something I'm even confused about, is if I'm publishing data to some relays and I query another relay for maybe tweets from Jack, how do I know that somebody published tweets to that relay? I'm going to figure that out, talk about it in the next video. Thanks for watching.